And the first person I'd like to introduce is Robb Walters. Robb is the CEO of Integrated Plasmonics. He has a PhD from Caltech, correct? Yep. I'm not going to try to explain what he does because I don't have a PhD from Caltech, but Integrated Plasmonics is a very exciting company. They're based up in San Francisco, and Robb, I'll let you go ahead.
Okay, great. Well, thanks very much for the introduction. I'm here today to tell you about my company, Integrated Plasmonics. And I imagine Plasmonics is a word that's maybe unfamiliar to most of you. What it is an academic subdiscipline. It's a subdiscipline of nano-optics, and it's where I spent 10 years in academia doing basic research, first at Caltech and then overseas as a postdoc in Amsterdam. Thanks. And so in late 2010, I left academia to start a company to try and bring Plasmonics, this technology, into the real world where it could actually make an impact. So the name of the company, Integrated Plasmonics, is a bit of an homage, if you will, to a company that I think everyone here has heard of, which is Integrated Electronics, or Intel. And Intel has done a fantastic job of commercializing the science of semiconductor physics in the space of data processing or information processing. And I believe that Plasmonics can have, similarly, can have a very large impact in the area of sensing or information gathering. So, arguably the most interesting system to gather information about is the human body. And there's a lot of companies now starting up, taking advantage of cell phones as sensors, and also decreases in the cost of semiconductor accelerometers and things like that, to do things like count your steps or measure your heart rate. Or for example, like this pink trace down here at the bottom, you can get a scale that connects to the internet and lets you track your weight a couple times a day. And so this is actually my weight over the last year. And one thing I've learned from tracking my weight is that you really don't have a lot of excuses when you start to see that trend line go up after a couple of days. So I'd like to see the similar kind of data, but for the numbers that are on the inside. Human beings are biochemical machines. And the fact is that there's no technology today that can let you practically build up a longitudinal record of your internal biochemistry. And that's really what we're trying to create, tools for personal monitoring of biochemistry. So we made a lot of progress in the last year, particularly since we closed our Series A investment last February with Social Capital. We've grown from 3 people to 20, and that's probably what I'm most proud of all the accomplishments. We put together a really awesome team, about half of whom are PhDs. And we put together a really diverse team, which is really important, because the problem we're trying to solve is by its nature extremely multidisciplinary. You need programmers and data scientists, but you also need electrical engineers, mechanical engineers, people that understand manufacturing, all the way down to chemists and biologists and physicists like me. So we put all these people together and built a facility. We have a 1,200 square foot clean room where we put all the tools we need to iterate on our product under the same roof. And that's been a huge efficiency multiplier for us. So in that facility, we have demonstrated our core technology. That is to say that we've run through a whole menu of off-the-shelf clinical chemistry tests and shown that we can do a range of colorimetric and scattering measurements. And off the benchtop, in the portable form factor that we want to eventually sell, we've shown hemoglobin, because you don't have to separate plasma. And we're moving rapidly towards our first multi-channel test this summer in a couple of months. Now, at the same time, we've been actively accumulating an intellectual property portfolio. We're one of the first companies to commercialize Plasmonics, so we really have an opportunity to define our own sandbox, so to speak. And we've been fairly successful. Like we put it in so many applications that through our IP attorneys, I actually got an invitation to go to the patent office and lecture all the patent examiners about Plasmonics. So we did that 2 weeks ago. It was a real experience in how government works. So I can talk to you guys about that later. But if you're not a true believer in the long-term promise of quantified self, it's worth noting that all of the things that make a consumer diagnostics product possible would also constitute like the ideal point-of-care diagnostic device. So it has to be cheap. It has to be convenient in terms of the sample collection volume and method, the time to result, and it has to be accurate. I mean, all of us at the very beginning of this company said, look, we're scientists, no magic 8 balls. So we really want to make sure that what we deliver is competitive with other measurement techniques. But there are a couple things that are unique value drivers for a device that would have broad scale applicability. And that is design, both in terms of the actual product itself. It has to be something people want to use. And in terms of the app, really, if you start talking about measuring dozens of biochemical markers over time, you have to be careful about how you translate that into information, either in a clinical setting or for a consumer eventually. And then another value driver that I think may not be as intuitive comes from my experience of buying every off-the-shelf ClioWave product, ClioWave.com, or Amazon even sells some of these instruments. And you know, in addition to having poor design, they also are sort of unsatisfying, because you prick your finger and you bleed on a cartridge, and you wait a few minutes and tick, 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 and 235. That's all you get. And it's just kind of like, wow, I bled for that. So I really think that you have to give people more than one number, and that's how we're going to build value for the experience in the long run, is really showing people that you get 4, 8, 16 numbers at a time. So if we think about positioning ourselves relative to other sort of diagnostic technologies or diagnostic practices, we want to break with the sort of dominant trend where you have to incur a higher burden in terms of direct costs or hassle in order to get more information from the same sample. So we want to stay down here at the very low cost side, but move up in the number of analytes we're doing. And for those of you that can see the screen, this is a chip. This is a little PLCC package. And that's how we're going to be able to keep costs low and move up. Basically, because we're attaching our technology to a semiconductor process, which scales like Moore's Law. So, with a little bit more detail, this is what we're doing. We're taking this core scientific toolbox of Plasmonics, which really talks about how to optimize light-matter interactions, and combining it with CMOS image sensors. And these are the camera chips that are used in cell phones. So, probably in this room right now, we have 150 CMOS sensors. And if you think about a typical cell phone, that has maybe an 8 megapixel camera in it. That chip costs a few dollars, and it provides you with 8 million photodiodes that you can read 30 times a second. That is just a torrent of digitized information that can basically saturate the microprocessor of your choice. So by combining that data stream with Plasmonics, we can use an off-the-shelf, low-cost component to measure biochemistry. And that's what lets us really contemplate taking the functionality of a reference lab and putting it into a device that is inexpensive enough to be sold to a consumer or sent home with a patient, or alternatively given to a practitioner. And this creates enormous opportunity. Obviously, the big one that we see is changing what it means to be healthy globally, to give people this sense of their internal biochemistry as an important element of health. And of course, along the way, we can work within existing point-of-care markets, particularly professional point-of-care diagnostic markets, or potentially even have an impact in areas where clinical labs are not available for logistics reasons. So that's a big dream. We have to talk about how we're going to get there. So we've thought a lot about this, and our current thinking is that the best first use for our product will be in chronic disease management and screening. And so towards that end, we're pursuing a device that simultaneously measures A1C and your lipid panel. And we think this would be great for people that suffer from several chronic diseases at once, which is, I guess, fairly prevalent among diabetics. So the devices that we're putting together right now, if you believe the engineer's Gantt chart, they'll be here on July 15th. Those will have the capacity to measure these 4 samples. And between now and when we anticipate starting our trials at the beginning of next year, we have to move to manufacturing on the cartridge side. There really aren't any shortcuts that rapid prototyping can get you so far, but you have to go to injection molding to really have the repeatability to demonstrate accurate detection. And so it's a really exciting time for the company. We're on the verge of placing our product in the hands of customers for the first time, and really interested to see what feedback we get from that process. At the same time, we're thinking about how to ramp production up and starting to think about how to engage with the FDA. To date, we've stayed, from the FDA's perspective, in a research mode, because as soon as you tell them you're doing development, there's a whole lot of ISO rules that apply to how your engineers do things and kind of slows you down a little bit. So we anticipate coming out of stealth in some sense. We've been very quiet about what we're doing, mostly just to avoid the distraction. But sometime this fall, we're going to we anticipate coming out and then looking for a Series B to continue growing the company. So thank you for your attention.
Thank you.